So just by way of introduction, I'm Richard Robinson. This is my first time here at this conference. This is great, and it's good to be in person conferences again. I work for a company named Bongo. We do a lot of ed tech, and so I'm just going to tell you a little bit about that so you know the perspective I'm coming from. But really, I'm going to talk about smart, high quality, solid pipelines. We all have pipelines of various sorts that we release things with. And I'm by no means an expert. I've got a team of experts that are really good at pipelines in various companies, and we've got them together, and they have some good experience. And so hopefully you'll get some nuggets or some principles or some ideas based off of that. But a little bit about where we come from. So our company, we actually do a lot of video technology that allows online learning of various sorts. And so especially focused on those things that are a little harder to do online and are better in person. So the soft skills, the communication back and forth, the things maybe in a medical industry that it's much easier to demonstrate I know how to do something rather than check a box or something. And so we facilitate the practice of that, the mentoring and coaching that happens all over video and various workflows there. Even presentations. I'm not a presentation expert either, but we have a lot of tools that help people get better at that, or language learning or things like that. So it's a lot of video technology. This is one example where we have a video and then we analyze it and see how fast is somebody speaking or how slow. Usually you can think back to the high school speech class you had or something like that, or the first time you did some of those speeches. And at least for me, I just raced through it, right? I mean, just really, really fast. And so the comment back from the teacher was, slow down a bit, make sure people can hear you, things like that. Maybe even vary the speech. We also look for filler words. I definitely use filler words, so you can count them if you find some, but there's things like so and other things that we say in English. Other languages have their filler words, and we support a variety of different languages, and so we highlight that. So my team does all the infrastructure and all the technology behind the scenes on this stuff so that we can actually tell how clear people are speaking. We actually tap into a lot of the Amazon stuff. So the Alexa stuff that we were just talking about, I definitely can, that resonates with me because there's a lot of cool technology, but we need to apply it in just the right way so that we actually can, people can get good feedback on their speech or on their presentation, and they might be just describing something they know or practicing what they know, and then they get that feedback and then can submit it. So it's kind of fun. We've been training it on various TED Talks and presidential talks and other things like that. So that's been pretty interesting to see, well, what is the proper rate of speech, for a given talk? Politicians are kind of hard because there's lots of clapping and stuff, so it skews our metrics, but we've been able to chop it, or good professors or things like that. So it's interesting technology. We're deployed throughout the world. So we have users, the little blue dots here, you can't see too well, but are our users. And so we'll have millions of users logging in around the world into these different locations. So we've got some in Asia, Europe, South America, East and West Coast here in the US, and then up in Canada. And so how we deploy into some of these environments and how we regularly move things through and get new technology out to our users is part of what I'll cover today. But just a little background where I'm coming from. At other companies, I've been in on-premise software, SaaS-based software, different cloud providers, other things like that. So there'll be some overlap, but some things you can probably relate to. So I'm going to talk about pipelines, specifically CI/CD pipeline, or continuous integration, continuous delivery, or continuous deployment. We really want to get all the way to deployment, not just delivering some software and then there's manual pieces. And I'll talk through some of the evolution we've seen that has taken us, I don't know if a pipeline's ever really done. It's continually evolving and progressing, but yeah, we've come from, I guess, a pretty rough spot, and I'll describe some of that and some of the things that led us there, because you usually can't turn off everything, or sometimes you have a greenfield project, right, where you can just set up a new project, but sometimes, a lot of times you have something that has to regularly release now, and so you're kind of iterating on that and improving it as you go. So anyways, as we're talking about coding, building, integration tests, that continuous integration that happens kind of internally as we're integrating code continually, and then you're wanting to deliver that and deploy it out there. We definitely have a lot of great things in the time we live in that allow for some of this, where we haven't really, I mean, I think back in years past where we had to custom build a lot of this stuff. There's a lot of really good open source tools out there. There's lots of you guys and others in the industry doing this. And so, so there's actually some really good help to be able to make our pipelines work. So I want you to think about pipelines. These are some images from Dolly, as I put in like futuristic pipelines or instrumented pipelines, and it came up with these shiny pipes with screens on them and other things. So I want you to picture, though, your own pipeline. So whatever it is that gets your application or your code into the hands of users, into production. So think about how that works right now. And maybe one of these images, you know, strikes you as, oh yeah, that's what mine looks like, or that's what I want mine to look like. I don't know. I'm kind of partial to the blue one or the shiny pipes with some screens on there. But I'll just tell a quick story. So as I'm from Colorado. We have lots of good winters and stuff there, and a lot of snow around the holiday time. And so I remember going to the mall quite often when I was a kid. And they'd always set up this huge like marble maze thing made out of wood. It was tall, it was wide, you couldn't really touch anything, but there were several marbles kind of rolling around in different ways. And you could just watch the marbles. So as my family would shop or something, I'd shop a little bit. I'd just watch the marbles. And I was like, this is cool. And it just goes, you know, those things, little drops here, and then it just keeps on going. And sometimes the marble would get stuck. And then you kind of have, somebody would, you know, I don't know, after hours nudge it or something like that. But they'd have multiple marbles, so there's always something to watch. But I think you guys can probably appreciate this concept of pipelines and some of the marbles that get stuck. So here's my visual. It's kind of rudimentary, but I want you to think about your own pipeline and see if any of these pieces kind of resonate with anything that you have in your pipeline. So we start with some piece going into the pipe. You can see there's different kinds of pipes. This is kind of interesting. Not a lot of consistency there. We got some water wheel that's pushing it up. This poor tired thing. This is kind of representing somebody doing some manual step again and again and again to push to the next level, right? And then it drops out. I kind of like the Super Mario pipe there. Back in the 80s, that was, you know, state-of-the-art pipe, really cool. Yeah, nowadays maybe should be upgraded, but it's still used in some part of the pipeline. Some precarious stuff, really precarious. If you're familiar with Rube Goldberg machines, that's like the specialty that he used to cartoon was, you know, the crazy, overly complex, precarious stuff that would do some simple task. And so eventually the ball gets through here. There's the pipe that's lean just right, so it rolls. You can kind of appreciate that in your projects maybe, or certain pieces of your pipeline. There's some old piece that somebody's working on actually at the moment, trying to make sure it's working and going through. And eventually we get something released. And so the package drops out the other end. And nobody is the wiser of what happened on the back end to actually make all this work. But it affects the quality, and it affects what actually is produced sometimes, or how often it can be produced, or when it comes out, or, you know, any of those frequency things that kind of get involved. So anyways, that's how I kind of envision some of our pipelines or some pieces of our pipelines as we evolve them. And so it can be anywhere from the unreliable pieces. So think in your own pipeline, you know, is there something there that maybe isn't as reliable as we would like for whatever reason? Pieces that require the manual effort. I know at different times in my career, I totally identified with this tired person that's trying to push this out at different times. Inconsistent pieces, I mentioned the different pipes. Brittle pieces requiring constant fixing or manual intervention or workarounds or things like that. All of those kinds of things that get in the way of a really smooth pipeline. So those are the kinds of things I'm going to talk through well, how do we address that? And this is by no means comprehensive, but there's a lot of different things we can do to address different problems or issues in our pipeline to make it more high quality, more solid, more automatic and smooth, so the little marble doesn't get stuck somewhere and need nudging. So some of those pieces, I know when we took over a project that I'm on right now, originally it was just understanding, well, what are they doing today? What do we do to actually get bits in front of users? And so to understand all those pieces actually took a little bit of digging to understand who's doing what and which pieces are involved and for which components. Sometimes we released certain pieces more frequently than other pieces of the application. And so, and it wasn't consistent. This piece released in this way, this piece released in a different way, but understanding all those pieces. And one technique that we found really helpful is just a simple or complex checklist to actually go through all the pieces and ensure that, okay, if this is what's happening, how do we make sure at least it's consistently happening today and continue that process while we work on improving it? Because we definitely need to keep the flow going for now. We can take a few steps back, but one of the things that we in particular, and I don't know if any of you can relate to this, is we had a problem with downtime. Now we had a pretty extreme problem where it was like a 3 or 4 hour window of downtime where the users couldn't access the system, and then the new application bits were put in place and then things switched over. So it was kind of extreme, I say, because I mean, 3 or 4 hours for users was pretty bad. Now at the time there weren't a lot of users, and so the team before had determined that 2 o'clock in the morning, that was a pretty good time, local time, because we got our 6 geographic regions. And so whatever that 2 o'clock time meant, AM, for those users was kind of a window where a lot of people weren't using the system, or maybe nobody was using the system, and they could go in and make those changes. But we wanted to eliminate that downtime for users, and especially as we scale. Now we're seeing 24/7. There's always some users in the system. Maybe it's not 10,000 at the peak of the day. It's only, a few dozen or something at 2 o'clock in the morning, some local time somewhere in the region in the world. But then multiplying by 6, one of the things I really recognized was the wear and tear on the team was not good. I mean, here were a bunch of engineers that were responsible for, getting code out the door and among other things. And then we're asking them, oh, and on this frequency, we want you to spend these few days in strange times, and then try not to make any mistakes, because I know you'll be really tired. And I mean, it was just, this is untenable. So that was one of the key priorities. And then representative test environments, because we wanted to automate all this stuff and clean it up, but everything in production is set up in a really nice way. We needed to make sure our internal environments were set up in a representative way so that it would behave the same and we could generate automation. So can probably relate to that. That's an ongoing process to do that. So for those 4 things, I'll just kind of roll the first 2 together and talk about checklists. And I love this book. I highly recommend the Checklist Manifesto. Atul Gawande talks about, he's a surgeon by nature, but he talks about all these different industries, and he interviewed these guys building skyscrapers. He interviewed folks, obviously surgeons and doctors and other folks in the medical industry. He went and talked to the folks flying airplanes and building airplanes and making sure that that's really solid for us. And he came up with these kind of rules and processes and things that would help, and actually even made a difference in modern day medicine with simple things like go through this checklist and make sure you don't leave anything inside a person's body when you're done, doing surgery, or I mean, other simple things like that, or wash your hands first and then do this. It's like a sequence. And for really intelligent people, we're dealing with a lot of complexity in our lives, and you can imagine your pipeline again. There's probably a lot of complexity in it, a lot of complexity in your application and your software, and it's more than we can do. And so I love this quote that really the volume and complexity of what we know has exceeded our individual ability to deliver its benefits correctly, safely, and reliably. It's just too much for us mere humans without some assistance. And so that assistance usually comes in a lot of automation, a lot of tools to support that, and that's really good. And checklists. And our checklists, we've kind of evolved them over the years to determine, okay, from just what steps are involved. I mentioned that. And that actually helps a little bit in kind of painting this picture of, well, what is our current process? What is it? What's the sequence that needs to be done? Even some of the detail. It's almost like a documentation of, here's our current pipeline. Here's the list. Here's the things that you can do in different orders, and what can be done. And then here's maybe a link off to some detail. And so that was helpful. It also helps ensure that we actually, as we're building a new pipeline, or as we're augmenting it and improving it, that we know what the next steps are and we can correctly determine. We might even highlight in the checklist along the way, well, here's the piece that takes a lot of effort, or here's the piece that we often get wrong, or especially if there's a manual piece, here's an error-prone piece. Maybe we should automate that first, or get a tool that solves that first. So it's kind of a blueprint or map of what needs to be replaced. It's also really good for helping to communicate what are the next steps, how much have we automated, how much have we improved, what is the process, and what's the ROI that we're getting from that. And honestly, there's a little bit of a satisfaction level for us humans where we see, I don't know, there's something about checking it off the list, right? We've got these 10 things and check, and okay, it's done and it's satisfied and on to the next one. So there's some pretty cool pieces of this. I'll just highlight one of our checklists. This is a deployment throughout a bunch of internal environments, throughout our regular pipeline, which is an internal environment staging, and then 6 production regions. And we kind of just funnel things through that. And it started with a much larger list with other different colors. And then as we started automating pieces, we started coloring things. So the purple ones are completely automated, done completely, and that used to be just, I don't know, tons and tons of steps, and now we just have a few to remind us, oh yeah, here's what it's doing during this phase. And then we have other things we kind of highlighted in a different color, green, that, okay, this part's highlighted, but it requires somebody to do a pull request or a merge request and then push that through. And then once that goes, we've got some hooks that then trigger things. We're using GitHub and GitLab and kind of moving to GitLab and consolidating a lot of things. And then as part of that pipeline, a lot of these things just happen as part of that pipeline. And so we can kind of raise that up to a higher level of, here's just the reminder of what the pieces are and the proper sequencing. And it's almost a plan of, here's the release. And if this one's a little different, here's what's going to be needed. And then we kind of fill it in. You can kind of see the things going from in progress to completed, and you can kind of watch this happen. Now, obviously, this needs to be fed with a full automated system at some point, but for now, at least gives us the scaffolding or the blueprint of what do we need to do to, one, ensure that what we're doing today is solid, and 2, move toward those next levels. So that's where we've found some pretty good benefits. Sometimes we'll actually put in a column here that shows, like I mentioned, how long it takes, and that can be really good for ROI. So as we look at one task and we say, yeah, it used to take this long for every environment, and you multiply that by all the environments, and it was error prone, and now it's automated and fully works. And that's a pretty nice thing to be able to communicate to upper management or the other teams to recognize this progress as we evolve our pipelines. So we're going to continue that even with other pieces of the pipeline. It's like, well, this tool does it this well, and it takes this long, and we actually just moved a bunch of our automated tests into a system that runs almost all of them in parallel rather than more sequential. And so what used to take 10 minutes at a certain part of the pipeline, which is kind of a long time in a pipeline, or an automated pipeline anyway. I mean, it used to take humans a lot longer than that, but now we can run it all, within 30 seconds or something. But they're all running in parallel, and so you can parallelize pieces that are maybe extending out. So kind of a good way to look at things. This can even be used in different QA aspects. So if you're looking at a checklist of, okay, what do we cover for this particular release or this particular feature, or especially new features, we found this very valuable. As you just It's again, the so much complexity and so many different types of tests. What do we need to focus on? And is localization or accessibility or some other piece important for this? What about stress testing or scale testing or performance testing for this particular piece? And there's just so many different types of things to keep in mind. It can be good to just kind of run through this. And for those that might not know what it is, security and privacy. Oh, well, what about FERPA, HIPAA? What about PII? What about for this particular feature or this thing we're doing for this component? What does that mean? How are we going to cover it? And then go through that list together and even throw in, okay, here's the plan, here's some stories or things to run through that and make it work. Or a lot of this is actually just part of our done criteria. If you're using Agile, right, just put it in the done criteria, but then a checklist is part of that to run through can just help all of us because we're going to forget, right? It's like, oh, I know this stuff down. I'm going to run through my list and I forgot something. Oh, accessibility, I forgot that. Or localization. Oh yeah, we need to do that piece. So can be just a good reminder for us as we're dealing with all that complexity. We've even taken it to the point of, this is just an example. Our components aren't numbered 1, 2, 3, 4 to 10, but as you see release 1 versus release 2, there's changes. There's more changes in particular areas. And if everything's fully automated and fully done, which we're getting to that point, but there's pieces and especially legacy pieces that aren't there and we haven't had the ROI to actually do that. We say, well, let's tailor it to where the changes are. There's going to be some risk there, but if there's a lot of changes in this area for this release, we're going to focus more effort there. We're going to run the full battery of tests, especially the tests that take a while or take a lot of engineering and AWS resources. We run in AWS, and so everything costs. So where are we going to run those things? And it might change release to release. On the eliminate downtime part. So I guess by hands, maybe just for folks in the room, does anybody have a process right now, and it's okay if you do, don't be embarrassed, that as you deploy into production, there is an interruption for end users while the new bits come in and the old bits go out? You have a couple nods, a couple hands. And sometimes it depends on the, I don't know for you, it's like which component, right? The new stuff, we do a lot of serverless pieces. Man, those just come in, there's no problem. We've got a really smooth pipeline. Some of the legacy pieces, it took us quite a while to get to the point where there wasn't at least a blip. Or, if you're doing database things and it takes a lot of coding to do a lot of backward compatibility or other pieces. So that, if you're not doing that, you might see this blip. You can even schedule the blip to be 2 a.m. and maybe you're not even online, but there's some of that, and it's pretty common. So there's lots of approaches to deal with that, and it takes a fair amount of work to take it out of the system completely and keep it out, right? Because you take it out and then it's like, oh, this feature, well, it's going to cause this little blip and this inconsistency, so it's better if we just take everything down for just 1 minute. It's like, 1 minute. Now we can't release in the middle of the day. And that's kind of my strategy for the team is, hey, can we release in the middle of the day at the peak? That's kind of the bar. And every once in a while, we give a little bit of leeway there and do something, if it's super risky or it's going to do a blip. But anyways, so limiting downtime, it depends on what kind of software we have. How reliable does it actually need to be? Or the downtime, how significant is that for the users? Maybe it's not a big deal and they just refresh and go on, or there are times when a lot of people aren't using it. How much risk can we tolerate? I like this, another good book, the Google Site Reliability Engineering book. It's an O'Reilly book, but it's fully online. Definitely recommend. A lot of really good principles, good concepts and ideas to consider. And they just mentioned that you balance the risk of unavailability with the goals of rapid innovation, efficient service operations, so that the user's overall happiness, we want happy users, with features, service, and performance is optimized. And for some systems, that means zero downtime, nothing. For other systems, it's like, yeah, you can tolerate a bit of that. Even for response time, what is that goal? Well, for some systems, it has to be super fast. For others, their browser is going to be slow enough that if it's a second versus 2 seconds, that can be tolerated. It's kind of that risk tolerance. Where is that at? So you have to weigh that for your own company, your own pieces. So eliminating downtime, some of the strategies, I won't go into detail on all these, but happy to discuss more of them if you're curious about some of them or how to apply some of them. Blue, green, black, red kind of approaches are some of the industry's typical ones where you're bringing in bits and then you're just flipping from red to green or red to black and blue to green. Rolling upgrades where you're updating some of a cluster of nodes and some of them are getting the new bits and some of them are running the old bits and eventually all of them get replaced. And so you're smoothly doing that as requests or load on a particular node goes down, then they just kind of filter out. And it's a nice way to think of your industry, of your nodes and clusters. You probably have heard the pets versus cattle, right? And so pets you name, every one of them you love and you keep around for a long time. Whereas cattle, it's just like, yeah, I've got a herd of 1,000 or something. And so you want to get into the mode of, I've got clusters of things. I've got things that just come and go and I'm not too attached to them. Maybe you'll name them, but you don't get too attached. They just come and go. And that's how we deal with things. You just assume things are going to die in environments. You assume the worst and you figure out, what can we do to move that through. Canary releases, it's the canary in the coal mine. Some users have problems where you're starting to see error in production as it goes out. Something's got to be changed. The nice way to do that is a feature flag where you can just toggle it off and the new feature goes away and it goes back to the old mode. And then you have to clean those up. So there's a whole engineering process around backwards compatibility, keeping the feature flags up and going through that in a solid way, rolling back, etc. Really, one of the most important things I want to stress, testing, I don't think I have to stress with this group, but the health and monitoring. It's so important to understand and have visibility into what is actually happening in your pipeline, internally, as well as in production. How healthy is it? Where are the errors? If there is an error somewhere, is that being bubbled up? Is it being caught? Is it being thresholded and alerted on? So important just to be able to understand that thing. You can imagine a canary in the coal mine. If you don't have a canary, all the coal miners die, right? So, you got to have really good canaries or really good monitoring of that canary or understanding of what people are experiencing. And you roll that as far back left as you can, right? You shift left. So even in our development environments, we can put monitoring and instrumentation in place and understand what's happening, but definitely through the pipeline itself. And like most people, we've got our pipelines not in the perfect condition we would like. And so it's determining, well, where is the greatest risk? Where is the greatest, I don't know, where we've seen problems before? Let's get those things and attack those things first. And honestly, that actually gives engineering time back. I love that because, we have this time and what have we spent in toil or engineering time just dealing with things or working around things. If you look at those things, then you can identify, well, here are the things to attack first so that we can get control over this. And then apply that engineering time saved to the next problem, and it just snowballs in the right direction. So our story of going to that 3 to 4 hours downtime, 6 environments, a bunch of engineers, the wear and tear was just unreal. So we did a few things. Develop deployment processes. We definitely did the process of understanding everything that was happening, make sure we could consistently do that process, and then start putting in blue, green, and other methodologies, even where it was really hard, so that we could do that zero downtime and start moving that from 2 a.m. to just any time during the day when the engineering team was there. A lot of benefits from that, because then if there is a problem, everybody's right there and can engage and look at the logs and look at that, and you can roll back quickly. Dockerization, cleaner deployment steps, all of those kinds of principles. There's lots we could go into there, but that's definitely key. Testing, increasing the confidence in our manual and automated tests. So probably a lot of you start with manual tests as well, and then go to automated. There's different ways of approaching that, but getting the confidence in those tests. Years and years ago, I used to love running our tests against a system where the system wasn't installed or something like that, especially if it's checking a whole bunch of infrastructure and logs and other stuff. And there's ways to test our tests and make sure that they're really doing what we expect, and then getting enough confidence that we can actually have the pipeline automatically push, especially out to production. That's a really scary thing, right? It's like, do I trust my tests enough that we'll just run them and then throw it into production and I have confidence it's going to work? It's a good test, and always there's some spectrum there. The automated deployment steps, the better internal test environments, that was a really big effort that we went through to make sure. I'll talk a little bit about that. And then automating the complex and brittle steps, looking at that pipeline. Again, think about those areas in your pipeline that are probably the most brittle or the most challenging. That's what you want to target first. And then adequate reviews, good design. Even for the intermediary steps, we actually did some projects where we had pieces that just automated everything or had a placeholder for automation, even if it was just some more rudimentary tools that we wouldn't keep around forever, but it was additional scaffolding that took the work out of the system, made that marble go and continue to go, and we knew it was there, but it wasn't the final piece. And so sometimes that makes sense to do, and then to continue to build that out. So you get some good benefits over time doing that approach. Internal test environments, just a note on that. Obviously, you're mimicking the production environments. Anything we're writing, we want to make sure, well, if it's going to behave this way in this environment, it's going to behave the same way in production. And so there's a whole discussion you could have on that, just making sure that those things are consistent and keeping them in sync, right? Because as everything revs, you want to make sure that that production environment and the internal environment match and are solid and continue to work. So monitoring, permissions, similar sizes, representative data, of course, with the security pieces there that you want to make sure that your PII is covered, anonymized data, all those kind of aspects. But as you look at your app, it's been interesting. There's a lot of, as I've looked at various apps over my career, there's a lot of overlap of the things that you definitely want to make sure are consistent. And then there's some unique things to each industry and each application and each group that need to be considered. And usually the team is the very best for fleshing those out and understanding, anybody who knows the app really well. Behave the same as production. I think that's the main thing there. So components of a solid pipeline. So how do we get from that Rube Goldberg machine with all those things precariously there and the manual effort and other pieces to more of a solid pipeline? At least this is a visual that makes me think of a solid pipeline. So you've got code kind of going through in a really consistent way. The pipes are all clean and consistent. There's no Super Mario pipes anymore. I've got little squiggle graphs around and other monitoring and really demonstrating that you want instrumentation each step of the way, right? You want all these pieces so that you can actually really know what's going on, where pieces are at. And if there are problems, and just assume that there will be problems, you've got the right things to detect it, to deal with it, to roll back if necessary, to catch it. A test fails. Okay, great. We don't proceed at that step. We leave that, or we roll back the last piece. All of those things can be automated. And the nice thing, again, is there's tools these days that provide a lot of this. And we're not the only ones doing this. And so there's a lot of really good, even open source tools that we can apply here. These are only some of the components. There's a lot of other components to a solid pipeline, but these are ones that I wanted to highlight. Flexible and maintainable. I think one of the challenges is always there's so much variety. Even if you have a greenfield app, there's the pieces that you've put in place, there's still variety. And with that variety, we need to make sure it's flexible enough to handle those pieces coming in and maintainable, so that as we're continually going forward, we get the perfect pipeline where for this particular set of bits, and then we put features on top. Well, the pipeline needs to be able to handle those new features, and it needs to be automated. And so one of the pieces that we want to continue to improve on and continue to update is that aspect with the bits itself, the version of the software that we have, and the version of the pieces of the pipeline. That's constantly changing. So we need to have a process to update those and all the tools that we use. Automated scans and tests, just put right into the pipeline. There's a lot of neat ways to be able to kick those off and run those in different ways to get good security scans, to get good static code analysis. We do a lot of licensing scans, other things. Monitoring, I mentioned, all along the way. Big fan of monitoring and understanding where pieces are at, and even in internal environments. And then the tooling and automation. So we're moving that human component. One of the high bars we have that really shouldn't be too high, but it was no changes can happen in production without a script or automation of some sort. And so now we've got a whole process, but that forces you to get automation in the front of your mind. And it comes with a lot of good auditing capabilities, avoiding human error, because anything you do as a human, you keep doing it, and then, okay, I'm tired this day, or I'm out of town and somebody else is doing it. There's just error-prone pieces there that we want to get out of the system. And one of those ways is to just lay it down and say, nope, it's got to be automated in some fashion. Here's what was run on this date to get it out. So drilling down a little bit into these, handling any of the code that needs to be deployed, plan for updates. And I really like this part of the done criteria. So you know what I'm talking about with Agile, right? So you got acceptance criteria for a particular story, and then done criteria applies to all stories. So any story that ever goes through, you ask the question, okay, it's going to need automated tests or documentation or other things. And some of those are really hard to hold to when there's a lot of pressure to get features out. Is that right? I mean, yeah, a few nods. I mean, it's just a pressure to, well, but we don't really need that test. We don't really need that documentation. And sometimes that can follow on in a sprint or something. So a little give and take makes sense. But one of the things that we've had some pretty good success, especially as we've shown how to do automated deployments, how to fit in an automated deployment pipeline, is every new feature, every new component, every new piece then comes with that automated deployment piece. And a lot of times my team will have to help the different engineers to put that in. How does that go in? And so that can be a give and take kind of thing as you evolve. Otherwise it becomes, obviously I have it self-service, so everybody's able to put it in and there's an established pattern and everybody knows how to do that. But part of that done criteria, just even thinking about, okay, this needs to go out and it needs to be automated. And if it goes out and it's not compatible with this piece, that's not going to work. So I'm going to need to build in a backward compatibility. It adds a bit of a tax onto the project, but it's so worth it because you get the benefit of that whole pipeline and the improvements, which can bring other challenges, right? Because we're shipping faster, and so all the features are coming faster than maybe we can test them, et cetera. Automated tests and scans. There's a lot we could go into here. You guys are probably the experts really on various types of tests, and you're learning a bunch of things here on how to do that, plugging that in any way into the pipeline, and then building that confidence, like I mentioned, in the manual and automated tests is just a huge part of this. And even factoring in some of these things that we think of as kind of side items. It's like, well, as I go through this part of the pipeline, and even thinking through which part of the pipeline does it make sense to run an accessibility test or a localization test or unit tests, and tying that to every pull request and merge request, or wherever it fits in the cycle, or whatever frequency makes a lot of sense. And then making that available, so that the engineers, so other people can see the results of those tests is a really good approach to just bringing all these pieces together and make everybody feel like, it's one team, it's one project. It's not, we're going to pass it over the wall and then it goes to the next step of the Rube Goldberg machine. No, it's all a continuous cycle. Monitoring. So we're big fans of Grafana and other tools. I don't work for them, I don't advertise, but I'm a big fan of monitoring. I've come from 2 other companies where we did a lot of monitoring for other companies and other applications. And so we use a lot of that to monitor our infrastructure, internal production, otherwise, the usage, how many people are using it, what type of day. That's how I know exactly what type of day or time of day is the peak of the day for our various users and such. Is we've got a lot of this monitoring, but understanding what the key health indicators, key performance indicators and things are for your application, your infrastructure, will be so useful to understand, is the pipeline working? Is it producing good code? And are things coming out there and working in the end? Tooling and automation, I'll just mention, don't reinvent the wheel. Enable things, and here's a whole smattering of some potential tools. You'll recognize some of the logos. Took off all the names, so we could have a little contest who recognizes the logos. But on the left, you got some code management, pieces and some CI pipeline pieces. I mentioned GitHub and GitLab before. There's some really nice stuff from HashiCorp, like Terraform, that allows us in the cloud to have everything, our whole infrastructure as code. That approach is so key, to be able to have not just, oh, I can click this button and make a load balancer, or this is how I configure that, but having that just as part of the code. In the same repo even is one of our approaches. And that can be really, really helpful. A lot of the automated test pieces, you'll recognize RSpec and Capybara maybe, and things like that. Backstage is an interesting one that Spotify has open sourced their microservice management platform, how they keep track of thousands of microservices. And we definitely are dealing with challenges with just hundreds of microservices at this point, but our engineers are producing more and more and more. And really, really nice tool to be able to just manage that. All the monitoring stuff, the Elk stack with Elastic, the Kibana, Grafana, even some of the security pieces. We run Burp Suite's penetration tests. We've got some things that grab evidence collection. You guys probably all have that for various levels, depending on your industry, right? That you have to do this for SOC 2 or for ISO or whatever. And so having automated collection of a lot of those pieces can really help accelerate the pipeline. So a few ideas to do, but going back to the components, going from the Rube Goldberg machine of these painful processes, the inconsistent pieces, the precarious, brittle pieces, the tired manual effort person, the person slumped over there with the water wheel. I think there's relatable pieces, even no matter how far along your pipeline is, there's going to be some aspect of this that we're trying to address to really get it to this point where it's clean, and that continual evolution. I really think it's a continuing problem that just needs attention and dovetails in really nicely with our quality and building solid software. So checklists in summary, big help there. Definitely recommend the book Checklist Manifesto, but even if you don't get that, just the principle of there's too much complexity for us as humans to really keep track of, put it in there. It's a great way to communicate the ROI and what we're doing and what we're doing next to improve and to show progress. Incremental progress, that ROI kind of builds into that. And then building in the quality, building in the automation and the testing throughout the pipeline. And thinking of that pipeline going all the way back to, I'm typing a bit of code here, to here's the user using it. And there's a lot of stuff that happens in between, but you know, that consideration is huge. There's lots of other parts of the pipeline. I won't go into that. Otherwise, just all the best in building your pipelines, evolving them, getting them smarter, more higher quality. It's a journey, and it always is, but it makes a huge difference. And with that, I guess, any questions from online or local? Everybody probably has horror stories about their own pipelines or the greatest desire. It's like, oh, if I could just fix this one piece in the pipeline, it would help this much, or the wear and tear on my engineering team or something like that. Yeah, question, go ahead. Good question. So the question's around the developers, the QA, the proverbial wall that sometimes happens as things go over and then push out. How do you bring those teams together, those individuals together with a pipeline and the communication of what needs to happen to get it out and to continue to support it? Is kind of the question. So I think that's a great question, because that's one of the challenges. How do we shift things left? How do we improve things such that pipeline isn't just, oh, that's these people's responsibility, and oh, the coding is that's responsibility. We definitely have specialists, right? And I'm a big fan of specialists because people gravitate toward things and are really good at certain things. And yet there's this need to be a full, complete team. And that's actually why I've been in QA for years and years, DevOps more recently, and I have a team with all of that, plus engineering in our company. So it's a great position to be in, because then I can kind of help some of that happen. Where I've seen that most successful is some of these checklists or some of these processes, like the done criteria. I rarely, there's every exception once in a while, but I rarely encounter an engineer that maybe is developing code that doesn't want it to be really high quality and well supported long into the future. But oftentimes they really haven't seen the good approach of how to do that. And so seeing how that happens, seeing the connect in the dots, and getting some help, from somebody that maybe is a specialist on how to do that automated piece in the pipeline, because they're like, I don't have time for that. Oftentimes that's almost like and I don't have any idea and I don't want to learn. It's like, well, let's do it together. Here's what we need to do to fit your piece in there. And as you put that in the done criteria, kind of a combination of done criteria and checklists and just regular communication, helps bridge some of those challenges. And it's different per engineer, but sometimes you pick up more of a hesitancy, but oftentimes that can be a great communication path, and being able to just demonstrate it with a few pieces. We had an engineering team, they were like, there's no way we can do downtime with a database. They just hadn't seen the techniques that can be used for red, black, and other things to be able to do that in a way that actually flips it over. And we had to learn some new skills, but then it like opens their eyes. Oh, that's so cool. You mean if I make that backward compatible, I can push anything out? I mean, there's more engineering in the sprint and it takes maybe more to do that feature, but now it's automated, and it's automated from then on, right? Every next change. So there's like this snowballing in the right direction kind of approach. Sorry, long-winded answer, but does that help? Any other questions? Are we at time?
Yeah.
We are at time. All right. Well, if you have other questions or other thoughts, here's my contact info. Happy to discuss. I like I said, I'm passionate about quality, building high quality software, pipelines, teams, individuals, everything that contributes to that. And it really is all one package. But thank you for attending today.